Exercise 1.5, problem 11 to 15. If x comma 2 and 4 comma y represent an identity function, okay, then x, y, s. So it's an identity function means each element is mapped to itself, right? So let's draw the domain and the range and put the elements there itself. So each element is mapped to itself. So x must be mapped to itself, right? And so that is why MC, this is your domain, right? X and 4, and the range is 2y. So that is why I've separated the domain and the range. So x must be mapped to itself and 4 is mapped to itself. So that is why I'm represented in the arrow diagram. So which means x is equal to 2 and 4 is equal to y. Therefore, their identity function is represented by xy, which is 4 and 2 and 4, right? Because it is x and y, it is not y and x. So x is equal to 2 and y is equal to 4. So it's option A. So in an identity function, each element of the set is mapped to itself. In other words, pre-image equal to image. That's what I've done, right? Because the pre-image and the image are both equal. So x will be equal to 2 and 4 will be equal to y. Right. Okay, let's move on to problem 12. So in this relationship, 7, 11, 5a represents a constant function. Then the value of a, basically that is what. So in a constant function, there will be only one image. All the elements of a or the first set will be mapped to only one number, that is a constant. So in a constant function, all elements a or the first set are mapped to the same element in B, that is the second set. There is only one image for all pre-images. So if you look at this, 7 is mapped to 11 and 5 is mapped to A, but it's a constant function. So there will be only one element, right? So already we have 11. So 11 must be equal to A, or A must be equal to 11. Therefore, the value of A is 11. Okay, I hope it's clear. Because it's a constant function, there will be only one image. All the elements of A or the set A will be mapped to A. That is, 7 also will be mapped to A. And okay, so 7 is mapped to A. But here, in this, as per this ordered pair, 7 is mapped to 11, right? So which means, and this 5 is also mapped to A. That's what it means. 7 is mapped to A and 5 is mapped to A. But we know 7 is mapped to 11 as per this ordered pair. Or in other words, A must be equal to 11 because there is only one image. So the image here is 11 and the image here is A. So since it is only one image, A must be 11. So that's how we find this answer. Right? Now let's go to problem 13. Okay, here the pre-images of 7 and 5. The pre-images are 7, 5 and the images are 11 and A. But we know there should be only one image. So 11 must be equal to A. So this is another way of, in the statement it becomes clear, I guess. Okay. So now I hope it must be clear. Let's move on to problem 13. Oops. Order is not right. Anyway, it's okay. Let's do the problem 11. 13. Given f of x is minus 1 of x is a function of from n to natural number to z. Then the range of f is, see, for all the values of x, right? So x can take any value, right? So it can take odd number or even number. When it is even, then what will happen? Minus 1 to the power of x will be 1. When it is odd, so what will happen? This will be minus 1 to the power of an odd number will be always minus 1. Therefore, the range will be always 1 or minus 1. You got it? It's pretty simple. F of x is so, and it's a function defining from n to z. So n from so the value of x can be odd or even. So if it is odd, the function will result in 1. Result in minus 1. If it is even, it will result in 1. Therefore, the range will be only 1 and minus 1. So it is option C. right? Then in this case, if function, the ordered pairs are 6, 3, 8, 9, 5, 3, minus 1, 6, then the pre-images of 3. So what is it? It's always pre-image, image, pre-image, image. That's the order, right? So pre-images of 3, right? What is the pre-image of 3? That is, in this case, it is 5. And in this case, it is 6. Therefore, pre-images of 3 are 6 and 5. Right? So that is option D. So please remember this, in ordered pair, it is always given this particular way. Pre-image and then followed by image. Problem 15. Okay. Let's set A be 1, 3, 4, 7, 11 and set B equal to minus 1, 1, 2, 5, 7, 9. The function is the function is defined from A to B, given by f is equal to the ordered pairs is given. Then they are asking us whether to show it as a one-to-one, on-to, bijective or not a function. In all these cases, first draw an arrow diagram. That is very easy and very clearly you will be able to get the answer. So draw the arrow diagram, list out all the elements A in the first one and list out all the elements B and then link them up as per this function. So 1 is mapped to minus 1. So 1 to minus 1. And 3 is mapped to 2. So 3 is mapped to 2. Right? And 4 is mapped to 1. So 4 is mapped to 1. Like that you draw the arrow diagram. So if you look at it, every element of set A has got an image and you have a different image. That is, no two images are there or no two images are there for in one element. Every element has got only one image, right? 3 has got 2, 4 has got 1, 7 has got 5 and 11 has got 9. So every element of A has only one image and in such a case it's a one-to-one function. But is it an onto function? It's not an onto function because 7 does not have an image. If 7 has an image, a pre-image, I'm sorry, then it becomes an onto function. So it's basically a one-to-one function. It's a function and then it is a one-to-one function. Okay. So I hope it's clear and thanks for watching this video.